Welcome guys. So we are starting a new physics GRE subject, new form GR9677. So we start from the first one and then go to the hopefully we can go 1 to 10. And if you think this is helpful, please subscribe to my channel. And I already done 4 of the GRE physics. So this is the final rest 2. So basically the capacitance showing so basically it start connecting A to S, and after that it's started to S to B. So basically you have a capacitance, and there's a basically Q which will dissipate. So there is a starting point is V. So why is it asking about the current? So basically you have multiple ways to solve it, but I suggest that you remember that when t goes to infinity, the capacitance will like open. So when t goes to infinity, the I should be 0, and then when t at the beginning, then the current is just V over R. So basically what we have is we start from V over R and go to 0. So this is the answer is the answer is B. The answer is B. And basically it should be exponential like over this. So this can be solved by, if you want to solve it more carefully, you can use the differential equation. And I is just dq over dt. So this is just voltage plus IR is 0, and then you have this. And you can solve this Q. You can solve this Q and do a derivative. And that's it. Okay. And the second is that there is a circuit. This is 5 battery is 5 volts, and then you have the uniform magnetic field decreasing in magnitude. So because from Lenz's law, when you know it's decreasing, then it means the Lenz law will start to will create the increased magnetic field from this. So it will produce the current from these directions, and which is which is different from the voltage, different from this. So we can assume that there is a the electromotive force, the electromotive voltage epsilon. Okay, so epsilon is magnitude is just the change of the flux. So change of the flux basically is the change of the magnetic field times the area, because now area is fixed. So area is 0.1 times 0.1, which is 0.01. And the dB over dt is 150 times this one. So you have 1.5. And the answer is different from it's opposite directions from this one. So the total ammeter reads will be, the total voltage is 5 minus this 1.5 is 3.5. So the ampere just 3.5 divided by 10, because it's 10. So the answer is B, 0.35. Okay, and for this one, it is old school question. Basically, you have a ring Q, and you ask about the electric field, the electric potential from this point. So remember that potential is 4 pi epsilon Q divided by R, and we should do the integral in general. But now all of these Q have the similar distance, which is x squared plus r squared. So the answer is just this. So this is the answer, large R. So the answer is B. Okay, number 4, small particle. Basically, you put in here and ask about the oscillations. Okay. So the force is basically dv over dx. So you can do the differentiation. Okay. And oh, this is the electric. I should not say the force. I should say the electric field. So this is the electric field. So the force is QE minus QE. So the total force is QE QQ Q times QX divided by this. And this term will equals to MA. But we don't care about what is MA. We just care about when R is really large, then we approximate this as QX divided by this 4 pi epsilon naught R cube. So this is K. This is K. It is K, and so this is the simple. It looks like a simple harmonic oscillation. Looks like a simple harmonic oscillation K. So ask you about the angular frequency. So angular frequency just K divided by M. Okay, so we have K divided by M, which is what? Which is A. It's obvious that you divide by M and then you take a square root. So it's A. Okay, number 5. The car travels at a constant speed, and the road and the diagram before there F air and air resistance, and which of the other force best represent the horizontal force. So basically you have constant speed. So that means there will be some force which balance this F air. So this is just we want to balance the horizontal part. We want to balance the horizontal part, right? But there is still this is the mv squared. This is the centripetal force. So the total force will be these two, which is FB. So the answer is B. Okay, number 6 is the block method as sliding down inclination. So we start from there's a object M here, and the coefficient of kinetic friction, there's a friction here, and if mass continues slide down, include a constant speed. And then what is the friction? How much energy is dissipated? Okay, so basically you can work out the force and do the integration, but I think it's too complicated. The total force basically is mgh plus the kinetic term, and after this is initial, and after the mgh is 0, and the kinetic term is the same because the velocity is the same. So the energy dissipated from the initial to the end. So the energy dissipated from the friction, just the initial minus after. So just mgh. So energy conservation tell me the answer is B. Okay, so number 7. Number 7 said there is a small mass m and it goes to 2m, and there's a height, and the collection elastically And when asked about what the 2m will start, how high 2m can go. Okay, so basically this is just ask about the elastic collision in one dimension. So the formula is that if you have m1 v1 and n2 v2, after collections you have m1 v1 prime, n2 is v2 prime. So the formula is you first calculate the velocity of center of mass. In here I call it VC. And after we compute the VC, then it's much easier than V1 prime just 2VC minus V1, V2 prime just 2VC minus V2. Okay. So we can assume then the velocity of m, at the collision, the small mass m has velocity v, and then we plug the formula and check what is the velocity of 2m. So we can assume that the m collision is v with 2m, and the 2m is has 0. So this is before collision, and after collision. So now vc is 3 over v, v over 3 from this formula. So v1 prime, which is minus v over 3, and this is 2v over 3. So the heights will proportional to the velocity square. So this is from the kinetic, and this is because the kinetic energy become the gravitational energy. So basically, all we have is let me see. So this is mv divided by 2, this one, and then we times 2 from the origin. You have v over 3 minus v, which is this one, and then from this one we have 2m equals 2v over 3. And after collision, the ball. So this is a ball, right? This is a ball. So ball is just from v to minus v over 3. So the height become 1 over 9 height. So the answer is A. Okay, so number 8. Basically, number 8 just So number 8 just asks you about your physics intuition. Suppose you have a pendulum and then there's a you have particle, we have simple harmonic oscillation, and then there's some force proportional to minus v bv. Then what? Then what is the period? So your physical intuition is correct. The physical intuition tell you that because there is a friction, so it takes more time to go back. So period will increase. So the answer is A. So the answer is A. Basically that's it. Okay. So this is just test your physical intuition. Okay, so number 9. So the hydrogen 8:1 ratio is the lowest wavelength of Lemon series to the Balmer series. Okay. So remind you guys that this is the energy level of the hydrogen. So the Lemon series has the energy 1 to n. So basically this is the energy difference, which is I should write it as a positive number. So I should write it as 1 over n squared, 1 minus 1 over n squared, so it's 2, 3, 4. And then we have the similar Balmer series. Basically, it's something goes through from n to 2. Okay, so this is energy difference, and the energy difference will be h times the frequency, and the frequency basically is speed over wavelength. So it's hc over lambda. Okay. So now we have the formula for the lambda for both series. So lambda is equals to hc over some constant, but 1 over, this is for layman. And for Balmer, basically it's exactly the same, but 4 minus square. And what it's asking is the longest wavelength. So longest wavelength means that the frequency is the longer, the frequency is the smallest. So that means which is the close, the first close. Longest wavelength frequency is much smaller. It's the smaller one. So from here to here. Okay. Oh, so basically we want lambda to be large. So that means this one need to be small. So 1 is unequal to 2, something 1 over 4. And for the second is something 1 over 4 minus 1 over 9. Okay, so we have the answer. Basically, this is 4 over 3. This is 5 over 36 over 5. So we do the ratio, we get 5 over 27. 5 divided by 27. So the answer is A. So number 10, internal conversion is a process. So basically, this is asking about atom goes to the internal electrons transition from atom. So this is basically the X-ray. But this is a common sense that usually when you see a gamma ray, so this means that there's a pair production. So the atom transition means the internal atom transition means the X-ray. And this question is familiar. It's common in the subject GRE. So I think you should remember the answer. Okay, so the answer is A. Answer is the X-ray. So we should choose B. Okay, so that's it. So I will see you guys in the next video, and be sure to subscribe to my channel. Thanks.